Open up the chat in case anybody puts anything in chat. One thing I want to do is we mentioned on Tuesday, we talked about static routes and about dynamic routing a little bit, but I want to make sure we also discuss kind of when we look at these two. So in other words, what is this trying to do? All right, hold on just a minute, folks. Drag this over here and figure out why it's doing that. I know why it's doing it. It's because I just changed my password, but I didn't want to put that all over everything. All right, so when we're doing routing, we've got two basic ways of doing it. We talked about I got my I got my tablet unplugged. Unplugged it earlier today. Let me plug it back up. Funny, the other day I couldn't figure out why I could not get my mouse to work right, and my this pen was sitting on the tablet up above my keyboard, and it was holding the mouse up. That was funny. But we talked about two different ways of doing routing. One of them is doing static routing, and the other is dynamic with a routing protocol. Dynamic. Okay. Now, when we look at these two, we look at versus static versus dynamic. The good thing about static, it is more secure. And one of the reasons is because we tell the traffic exactly how to move in the network. So it is more secure. Now, I will tell you this, we used to call dynamic less secure. Now, I will say that it is a little less secure because you're having routing choices made by and routes being automatically created with a routing protocol. But most modern routing protocols today now support authentication between routing devices. So while it is less secure, it may, saying it's less secure, it may be that it's less predictable as into the path, whereas static is more secure because we are very predictable in our path. Static is more admin intensive because what you got to think about is if you add a new device or a new network, intensive. If you add a new network, you're going to have to go back to all your devices and add in new routes. So there's more admin work involved in a static environment. It also, though, it uses less router, CPU, and memory. Because one thing you're going to learn is that with a dynamic routing protocol, you've got all these tables that are being built, like a neighbor table and a routing table, which is still being built with static, but the routing table is being built through the use of the dynamic routing protocol. It is, though, less scalable. Static routing really kind of breaks down pretty quickly when you get past just a couple routers and a couple routes. Dynamic routing protocols are very scalable. Okay, very scalable. We used to say that dynamic routing protocol took more admin knowledge, which it does a little bit, but this day and age, the dynamic routing protocols are so simple. Now, I'm going to mention a couple dynamic routing protocols. I showed you on Tuesday the very simple one, or talked about RIP, which is very old. There's RIP 1 and there's RIP v2. There's two different versions of RIP. One supports classless routing, or VLSM. One does not. We had an old protocol years ago called Igrp, Interior Gateway Routing Protocol, and now we use Igrp, Enhanced Interior Gateway Routing Protocol. You probably have heard of OSPF. You may have heard of IS. Anybody ever heard of IS or ISIS? That's an old one, not really in use very much. And then you probably have heard of BGP. All right. This protocol here is used to keep the internet up and going, BGP. We'll learn down the road a little bit more about the difference between what these are, which are interior gateway protocols, or IGPs, and this, which is an EGP, or an exterior gateway protocol. Okay, we'll learn a little bit about that, but not a whole lot. But I just want to show the difference between static routing and dynamic routing. I will tell you this though, static routing has its place. I mean, imagine a network where this is your network. You've got one router, you got your inside host or whatever. This is your internal network here. No, that didn't do what I wanted it to. It's your internal network here. All right. You've got one connection to your ISP. This is your ISP up here, and that's it. Dynamic routing makes zero sense on a network this simple, because all you need is a static default route, one static default route. Static default right here that says anything that I don't know how to get to, send it up to the ISP, let the ISP figure it out. So there are places where static routes make a lot of sense. Stub networks like this would be what we would call stub network, because there's only one way out of the network. That's where static makes a whole lot of sense. Also in very small networks, it makes sense. Any questions about comparing static routing versus dynamic routing? No questions at all on it? Okay, well, let's look at our different types of static routes. We have 4 types we're going to talk about in this course. A standard static route, which I've already showed you. A default static route, which I've also showed you on Tuesday. I did not show you a floating static route or a summary static route. Those 2 will show you that are a little bit new. But these can be, by the way, created using the IP route or the IPv6 route command. So you can do static IPv6 routes just like you can with IPv4. In the syntax for creating a static route, this is the syntax: IP route, your network address you're going to, the mask of that network, and then you've got some options. And you can either use the next hop address, which is the IP address of the router you're sending it to next, or you can use the outgoing interface. So if you know it was the S0 you're going out, then you could do that. Or sometimes, especially if we're going out what is an Ethernet interface, we do a fully specified route, which is next hop and outgoing interface. This typically is only used if we're going out an Ethernet interface. Okay, so let's take a look. Static route for IPv6, exact same thing, except it's just the IPv6 prefix and the prefix length, then either the next hop IP address, the exit interface, or both. One thing I do want you to pay attention here is this distance, okay? We talked about what's the administrative distance for a static route?
1.
1, okay? By default, it's 1. We're going to be able to actually set up what is called a floating static route by using this distance optional command. So I just want to mention that. We'll come back to it. But by default, it's 1, but you can affect it. If for some reason you didn't want it to be 1, you can set it to any number between 1 and 255. 255 is unreachable though, so you wouldn't want to set it to 255. I'd probably do 254. 255 will only be used if nothing else is available at all. So let's look here. Here's our topology we're working with. We've got a dual stack network where we've got both IPv4 and IPv6. Now, I want to ask you a couple questions on this network. Let's imagine we have all of our basic configs in place. We have all of our IP addresses on the interfaces, and the interfaces are up. How many routes would be in R1's routing table right now?
6.
Well, there's going to be 2 IPv4 and 2 IPv6, because R1 is directly connected to the 3.0 network and the 2.0 network.
Okay, 10 because it's dual stacked.
Well, it won't be 10. It's going to be, it depends on whether or not you count the local routes.
I was counting the local route.
Count the local routes, then it would be 1, 2, 3, 4, 5, 6, 7, 8. It'd be 8 because there's 4 networks it's connected to times 2.
Okay, so the R1 side, the R2 side, the PC2 side, and then the R3 side.
There's no, well, what I'm saying is I asked what would be an R1's routing table?
Oh, okay. Okay.
Just
Yeah,
R1.
All righty.
In R1's routing table, there'll be 2 entries for the 20. There'll be your network entry and your local entry. There'll be one for the ACAD2 network and the local entry, and then the same thing at the bottom. So you would have a total of 8, 2 IPv or 4 IPv4, 4 IPv6. Now, if I was actually asking, quite honestly, how many network statements or network items would be in the routing table, I would answer 2 IPv4, 2 IPv6. I would not count the local route as a network per se, okay? But that's important. How many would be on R2s? Let's just see. You basically would have 2 for each one of its interfaces. So you'd have 6, well, you say 3 v4, 3 v6, and so on and so forth. The important thing is to note that those starting routing tables, just like we have here, and that's what I was showing you, here's what we've got directly connected on R1. We got the connected and the local, connected local. On R2, we've got all of these connected and locals, and here's R3. All right, so R1 can ping R2, but right now, it cannot ping R3. And that makes sense because if I tried to ping 192.168.2.1, which is right here, even if I tried to ping 192.168.1.1, let's look at R1's routing table. 192.168.1.1. There's absolutely nothing in this routing table that goes to any 192.168. So R1 has no reachability over to R3, and vice versa. R3 has no reachability over to R1 because all of its networks are on the 192.168. So we got to fix that. Here's our IPv6 starting routing tables. It's the same thing. It's just showing you the routes that are there. And you cannot ping R3. Can ping R2, but cannot ping R3. So what we're going to do is we're going to configure some static routes using this scenario. Okay. So we'll go to R1, we create a route, and we say IP route 172.16.1.0, which is the network off of R2 that we have no routes to right now. And I'm going to say this mask, the mask for the network, because it is a /24 network, next hop IP address, 172.16.2.2, 172.16, and then do the same thing for the 10 network and the 20 network. And now you can see that statically we have a route to the 172.16.1.0. Now remember, this 1 in the beginning is administrative distance. This is the hop count, or this is the metric. So it's 0, but the AD is 1. And then we've got 1 and 2. So now R1 can ping R3, right?
Yes.
Technically, you're right, Steve. R1 can ping R3, but it will not get a reply back. Because R1, if it pinged 192.168.1.1, it would look in its route table. It would send that up to R2. R2 would send that down to 192.168.1.1. But when R3 looked in its route table to send it back, it would not know how to get back to this 172.16.2 network.
Right, because it was a one-way ping or one-way address.
One way. We've only set up our routes from R1 to R3. Remember our rules about how just because a route exists to the destination does not mean a route exists to come back from the destination. R3 would have to be set up with return routes for the 172.16.2 network and the 172.16.3 network in order for us to be able to have full reachability. So let's go down here and look. Okay, so R1, that's, by the way, that is doing it with a next hop IP address. We could create the same routes doing an exit interface. Why do you think we use exit interfaces sometimes? Works great with ISPs, by the way, because if the ISP changes the IP address on our exit interface that's going out to our ISP, we don't have to change our static route.
Yeah, that means it's always a constant.
Correct. It's just going to send it out S001, and then whoever's on the opposite side, hope it knows how to get to where we're trying to get to. All right. So what this is saying is, in order to get to those 172.16.1 networks, send it out my S00010. So it's going to go across. And since this is a point-to-point link, the only place it can go is to R2. R2 will then look in its route table and will find 172.16.1 because it's directly connected. And then would respond if it has a route back to R1, which it will have because it's on the 2 network. All right. So this is just doing it with an outgoing interface instead of the next hop IP address.
So if we have like a, let's say another one, R4 connect to R3, R5 connect to R4,
Okay.
and then PC5 connect to R5. So then in order to pin PC5, we have to add the address to R12.
Okay, let's do this. Let's paste this in. Let's try it and let's see what we got here. So here's the network we have. So what you're saying is we're going to add an additional network down here.
R4 connect to R3, right?
Okay, so here's an R4.
And then
Okay.
R5 connect to R4.
Okay, so we can do this. Here's R5.
Right. PC5 is connect to R5.
Way down here. Okay.
Right. So now in order to pin PC5 from PC1, all right?
Sorry. Yep.
What do we do to R1? So shall we add the routing entry there too?
All right, so let's imagine, I'm just going to put some numbers in here, okay? So I'm going to say that this is the 10.0.0.0/30 network.
Yeah, that works. Yeah.
.1.2. This will be 10.0.0.4/30. So this will be .5.6.
Right.
And then this over here, I'm going to make 131.107.1.0/24. This would be .1. Okay. So we would have to, on R1, okay, we would have to have a route that says the following. So we want to get to 131.107.1.0. We'd actually now, if we added all these, we would have to add 3 more routes to R1. We would need to say IP route, okay, 10.0.0.0, 255.255.255.252
right.
S010. And then we have another one to 10.0.0.4, same mask, same thing here, 010. And then we'd have a route to 131.107.1.0, 255.255.255.0 S010. And that would say anything going to these send up to R2. And then we would also have to make sure that R2 had routes down here.
Okay.
Now this, Dr. Hugh, is why static routes become very difficult to implement in large networks.
Right.
Because now we would have to add 3 more routes to R2, and we would have to add 2 more routes to R3.
Right.
So just as soon as these build, you get this kind of trouble. Now I will show you a trick here. Let me show you a little trick we're going to do. Imagine instead of using all of these, okay, I've only got, how many ways can I go from R1 to anywhere else?
One way.
One way. The only place I can get out of R1 is to go to R2, right? So I actually could handle all my static routing issues on R1 with this command.
Oh, okay. All zeros. Right. Okay.
It's a default route that says anything that I don't know how to get to, send it up to R2 and let R2 handle it. Because this is a stub network. R1 is a stub.
Okay.
Now, you can't do that for R3 if we've added these 2 on here because R3 has stuff below it.
Right, I have two choices.
But you could do it on R5. R5 could have one route that says anything I don't know how to go to, send it up to R4.
Okay.
Okay. So
Mm.
that's a special way that we could use a default route to solve the problem of trying to do so many static routes. It's not going to make life easier on us for R2 though, because on R2, we still have to put a route into these networks, to this network, and this network. So we would have to have what, 1, 2, 3, 4 static routes on, actually 5 static routes, because we need one to here too. We'd have to have 5 static routes on R2 alone.
Mhm. So that's why when we, for example, go visit website far away, sometimes we may not be able to connect, right? Because the
Right.
routing table is already full. You cannot
Well,
establish.
it's not necessarily the routing table is full. It may be that there's no route to the destination. So
Okay.
imagine, here's what could happen. Imagine if R1 was trying to get to PC5, but this link goes down.
Mhm.
R1 can't get there, so you get a destination unreachable.
Mhm.
So that's why it would happen. It's not necessarily the routing tables are full. It's just that probably a link that's going to that destination got broken. And if that link is broken, then you're not able to get there.
Mhm. Yeah.
So it's static routes are good, but they can lead to a lot of problems if you've got a large network. In fact, I would say really no more than 5 routers at most would be what you would want when you're using static. Okay. Now, our last item we talked about was a fully specified route. Notice how they've changed this to be, instead of a serial link, it's now an Ethernet link. So you use the outgoing interface and the next hop address. And this is because of the ARP table. It helps with the ARP table and helps with what's called a reverse lookup. It just makes life easier for you. So really the only time we use a fully qualified route is if we're going across an Ethernet link to a destination. So you'll notice it's same route, but we're going out the interface gig 001. So we also put in the next hop IP address. You can do the same exact thing here, except you notice they used the link local address for IPv6 instead of the next hop global address. They just use link local. That way, if the global address has changed, you don't have to change your route. Your route still works. Now, verifying routes, easy. Show IP route static, or just show IP route network number, or just show IP route will work too. That way you can see it. So you can do a show IP route static begin gateway, and it will show you just your static routes. I don't like to do this. I like to do a show IP route and see all of my routes, so I have a good idea. Here's looking at show IP route for a particular network. So this tells you how you're getting to the 2.0 network. All right. This will show you what's in the actual running config file. So show IP route pipe. Never forget that this is really a Linux-based OS. So most of the operators that you use in Linux will work on the iOS. So if you do a pipe section IP route, it will go and find that section and display it out of the running config. Show IPv6 route static will show your static IPv6 routes. Show IPv6 route, and then the network, it will show you that just like before, and same thing inside of the running config. So nothing there that's any really crazy. But this is what I've already talked to you about, and it's called a static default route. So if you've got only one way out of a stub network, there's no reason to put multiple routes on this network, on this router R1. The only way it's ever going to get out is through R2. So why not just put a route that says anything I don't know how to get to, that I don't have a route for, send it up to R2. It's called a quad 0 route, because you do 4 zeros, 4 zeros, quad 0. Now with an IPv6, you do it with :/0, which is a default route for IPv6. So all routing on R1 can be handled literally by 2 routes. In fact, if we go back, folks, if we go back up here to our network, as this network is set up, the easiest way to do static routing on this network is a default route on R1 that points to R2, a default route on R3 that points to R2, And then R2 would have one static route going to the 172.16.3 and the 201 ACAD3, and one static route going to the 192.168.2 and the Cafe 2. So you could have 4 routes on R2, 2 IPv4, 2 IPv6, and then 2 default routes, one on R1, one on R3. And of course, you'd also have to have your IPv6 default route. But that would take care of all the routing in this entire scenario. So our default routes are very easy to configure. So on R1, IP route quad 0, next hop IP address of 172.16.2.2.
So I wonder why use all 0? Why not use all F? Look like a sort of multicast, right?
Yeah, instead of using all ones, the ones is a broadcast, which means basically the ignore, whereas the 0 is, remember in our when you actually AND something, a 0 ends up being our, well, how do I say this? Our networks are zeros. Our networks have, for instance, if you look at 192.168.12.0/24, we're saying that the .0 is the host portion. So we say basically nothing in the host is available. Then these are all of our networks. So what we're saying is match any, this says match any network.
Okay.
And any mask.
Okay.
So that's just the way they decided to do it in the routing table, so that it would be able to match each one. I see what you're saying too. Why not 255, 255, 255, 255, 2 sets of 255s? And I think it's because when there's a 0 in the host portion, it's considered to be the network. So if we put a 0 in all these host portions, then that means it's all network bits.
Okay.
So
yeah.
All networks, if it matches nothing else, send it up here. And then here, by the way, you could also use, instead of the next hop global address, you could use the next hop link local address as part of that, if you wanted to do that for this route here. Verifying a default route, you want to look for the static route with the star. And it will also tell you the gateway of last resort is set here. So you can see that. And somebody sneezing. And then down here, you can see it was always listed as : 0. And that is your default static route for that. Okay. Most time, well, not most time, almost 99, well, I'd say all the time, we use static default routes only on stub networks. Okay. Now let's look at one more type of route.
Let me be accurate. So stub network means there is that lane only has one router, right?
Well, no, it only has one way out.
One way out.
Yep.
Okay.
It only has
Maybe
one way
two
out.
routers, but one way out.
One way out.
Not one PC.
No, not one PC, but no, it could be 2,000 PCs on the inside, but only one way out to the main internet.
All right.
So this would be considered a stub network because there's only one other routed connection. So
May have another router that's like a DHCP server, but that's only one router let you get out the lane.
Basically, think of it like this. We're going to use the default route on the stub router that is connected to the internet. So if a network has only one connection to the internet, typically we will use a default route. Now there is a way, and that's what I'm getting ready to show you here in a second. There actually is a way, even if this has multiple links. Now, let me show you here. It could be like this. Let me think about how I can show this. Let's go back one here. Let's create a new. Let's do a new. Pull this out of here. Let me do a new capture. Let me grab this. Control C. Go back on my whiteboard. All right, so let's do a control V here. All right, so let's imagine it is possible. Let's imagine that this was a network, and inside of here, there could be another router, okay? There could be another router here. But this is an internal router. It is not connected to the internet.
Okay.
And then down here could be more PCs or whatever.
Mhm.
Default routes go on the router that is the stub, and by stub, it's where your network ends and connects to the internet. You'll see there's only one path out.
Mhm.
So that's why it's called a stub, because it's only one way out to the internet.
Okay.
Now we're getting ready to show you something that's it won't confuse you, but one of the things you can do is what's called a floating static route. It is possible. Now, right now, what we would do if we were doing a route, we would do IP route quad 0, 0, 0, 0, 0, 0, 0, 0, 0, and then we'd say exit interface S0, 1, 0. That's going to put a route in the route table that has an administrative distance of 1. Now imagine that there was another internet connection. This was ISP1. And this is ISP2. Okay. We could actually connect another connection here. And let's say this is on S020. Okay.
Mhm.
We could put another route in here and put IP route 0, 0, 0, 0, 0, 0, 0, 0, S020, oops, S020. And then after that, put the number 100 or put the number 11 or 10 or whatever. If I put both of these in,
Mhm.
this one goes in the route table, okay? Because it's got an AD of 1. It's got a better administrative distance. This one's sitting there in the config waiting. When this link breaks, guess what happens?
It
Rolls over.
It rolls over to this one.
I've seen this used with a backup ISP.
Yep, that is called a floating static route. And this is what we do is we call it really poor man's dual home, because in an enterprise environment, we would actually run BGP. We would run BGP across these two links because we're dual homed. But if we're like I said, if we're not going to run BGP on the outside, we use a floating static route like this.
Mhm.
So that, by the way, is the whole use for a floating static route, or one of the big uses for a floating static route. Imagine that you had two different ways to get from your HQ to your branch, but one of them was through your private WAN, which is what you wanted to use 99% of the time. But if that private WAN went down, you had a slower speed backup link that was an internet connection that came through. You wanted that to work only if this private WAN went down. You could go in and do a floating static route. So you could do IP route quad 0, 172.16.22, which says go up to R2. So that would be the best route because it's going to have an AD of 1. But we put in a secondary route that goes through R3 with an AD of 5, or metric of 5. And so now that would only be used if the link between R1 and R2 fails. So that is what is called a floating static route. This, by the way, I don't like the fact they show it to you using the same network. They're testing the floating static route by breaking. They shut down the interface and it will start working, which it will. It's more common, instead of using a floating static route in a network like this, the most common is like this, when you're actually connected to two different ISPs, and one of them is your primary ISP or high speed, and maybe the secondary one is a slower speed connection that you're paying for as a redundant link just in case you need it. The negative about this mode with using floating static routes, the negative is that you're paying for two connections and only ever using one of them. If you can graduate up to using BGP and actually be what's called a true dual home dual homed setup, you actually can take BGP to load balance across those two. But it gets when you implement BGP, everything becomes crazy complicated, or much more complicated than what we're dealing with our static routes. Okay.
But isn't BGP mainly for the load balancing and not necessarily to get into a redundant ISP?
It is. It works for both. It's designed for both, to do load balancing if you have multiple links to a single ISP, or if you have links to two separate ISPs. It can do both. Yeah,
Okay.
BGP has capability to do both. Okay, and then finally is this, which you rarely see, but they're called host routes. And that is a /32 route, and they're usually put in as L's for our IP addresses that are on an interface. You could do a static route to a host. So this is basically saying to get to this one host, go here, but it's not used that often. Folks, will you give me just about 5 minutes? I'll be right with you guys, and that may be TMI, but if you do ever have a student in your class with a spinal cord injury, please cut them some slack, because it is not easy to deal with at times. But here we go, static host routes. You'll notice this says get to this one particular host. All right, and that's why it's a /32. Go to this IP address. Now the thing about that, and you talking about total control, we talked about security and control. That's pretty control right there. Okay, so that's telling the branch router how to access that server. You may, in your dealing with certain types of programs, actually run into a program that for some reason needs a static host route, so that every time a particular application is trying to go to a server, it knows exactly where to go. I'll be honest with you, I worked with networking for 25, 30 years, and I cannot remember putting in a host route. Maybe someone on the call here, maybe somebody in class has done it. If you have, please let me know. But like I said, I can't think of any time that I have done it in almost 25 years of networking. So everybody, that basically is static routes in a nutshell. Remember, let's go back and very quickly talk about our types of routes. Remember, we had a standard static route, which just points to a regular network. We have a default static route, which is our quad 0 route that is used typically if there's only one way out. We have floating static routes, which is a route that we have changed the metric on in order to allow it to be used as a backup route. And summary static route. Now, where did my summary route go? I missed something somewhere. I must have missed my summary route. Let's scroll down here to the bottom. Summary static routes. Well, now I'm confused because that's pretty sure we had those. Let me give you an example of a summary static route. Let's imagine. Let me give you first off, we'll talk about what a summary is, but we'll make it easy. I'll give you an easy example on a summary static route. Let's imagine that we had the following networks. We had a router here. Blue's fine. Let me zoom out a little bit because this is okay. So we got a router here. We got another router over here. And then for whatever reason, this router's got 3 Ethernets on it. And let's imagine that this is the 172.16.1.0 network /24. This is 172.16.2.0/24. And this is 172.16.3.0/24. And we have been told that this company, whoever this is, actually controls all of this network, 172.16.0.0/16. on our router here, R1 going to R2, instead of creating a route to this network, and this network, I could actually create a route and say IP route 172.16.0.0 255.255.0.0, and let's say this is S010. I'll make it into a lightning bolt, y'all. So it's a serial interface instead of a S010. So basically, this is now a summary route, because instead of doing a route to each one of these, I said, no, we can just use the 255.255.0.0. You also could have done this. There's another way you can do it, and that is you can actually summarize these 3 networks. So you take 172.16.1.0 and convert it to binary. Well, first off, you know that the first 2 octets are going to match. So let's just do the third, really. 1, 2, 3, 4, 5, 6, 7, 8. And then those are all zeros, so we know that's not going to be anything. Then it's 1, 0, and then it's 1, 1. So 1, 2, 3, 4, 6, 7, 8. 1, 2, 3, 7, 8. Missed one there. Okay. So what we do is we look and find where they match. And in this case, we know that the first 2 sets of bits match, so 16. And we go all the way here and we go, okay, and it matches all the way to right here, right? So that's 16 bits, 17, 18, 19, 20. It's 22 bits that match, okay? And so we could have written this as 172.16.0.0 255.255. And we look here and say, okay, so that's 2, take off 3, so 252.0 S010. And that would be actually the network 0 through 3. So you just have to be careful, because you've actually summarized the 0 network here too, because you'll notice that if I do 0, 2, 3, 4, 5, 6, 7, 8, those also match on /22. But notice the .4 network, look what happens with .4. .4 is 1, 0, 0, right? 1, 2, 4, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So this summary does not match. This summary right here, this 252, will not match the 4 network. It would only match the networks 172.16. 0, 0 through 172.16 3.0. So that's a summary route, and that's the basics of it. We don't get as much into it now as we used to. We used to get a lot more in depth inside of CCNA with it, but we don't anymore. That's just a way of writing a summary route. Okay. Any questions about static routes? I'll go ahead and tell you, I'm not going to do the troubleshooting today, but we'll talk about it when I get back from break. But basically, what is this? Oh, not break, my conference. Basically, 99% of the time, static route problems are you're pointing it to the wrong interface, or you put in the wrong network, or you just forgot to put a network in, quite honestly. That is most of the troubles that we get with our static routes. Okay, any questions from anybody? Please remember, next week I will not have class. I will not be here. And I do have class scheduled for the 21st at 2 o'clock, which is a Tuesday. And so that'll be our next time back. I do have the final exams on, and all other exams on, and the course feedback. And you can do your hands-on final for CCNA 2 inside of netlabs.stanley.edu. Anytime you want to. It's just the lab that says skills-based assessment for CCNA 2. So really at this point, the ball's in your court in a lot of ways, that for you to work and get finished up and get done with CCNA 2. And then you will we'll be beginning CCNA 3 in September 30th. So
our closeout is the 28th for all labs.
yes, I mean, the absolute drop dead date's the 29th. But the 28th is when I would like to have you done if you can.
Yeah.
That would be best. If you don't make the 28th, we've got 1 day of wiggle room, but that's it. On the 30th, we've got to be pretty much moving forward for the next class. All right. Any questions for me? I can't thank y'all enough for being here. Like I said, it's been a good group that's constantly been at all the meetings. So I am super happy. Like I said, I know Dr. Hewitt talked about teaching CCNA 3. I just signed up for my DevNet exam on September 28th. So I got, even though I'm gonna be on break or at a conference, I'm gonna be studying for my DevNet exam myself. So
I tried, probably I don't have the privilege to create the classes or anything there. Probably, I have to re-register in some like a instructor way or some other ways. The menu you show me do not exist on my side.
we can, Dr. Hugh, we'll get together and work on getting you set up to where your academy is running and everything's working. We can do that.
Okay.
Don't worry, we'll get you your account that you've been using to access the class we're in will be the same account used for your instructor account. We'll just make sure that we get it all set up on your end. So we can get that, we'll get that worked out.
Okay, thank you. Yeah.
Really what I wanted to do for a lot of this to begin with was just get you all going in the classes and get you going with the materials. And we can work as, even though you're going to be in CCNA 3, I will be working with you to work towards setting up your academies and getting those things going. So if everyone who doesn't have their academy running, we can talk about the process of how you do that and what you have to do. Many of you are at existing schools that used to be academies and have been reactivated. Some of you are at brand new schools, in which case there's a little different method that you have to go in and request to become an academy. And then if you want us to be your academy support center, then you request us to be your academy support center. And then you go from there. So
Unfortunately, with some of the staff at my school, this is going to be like mating elephants.